Hey guys, welcome to my channel, and today I'm solving 5070 paper 2 of October-November 2020. I've already solved its previous parts and I have put the link in the description below. You can check it out. I've also solved other year's paper which you can again check out in the description box below. I have put down the link. Without any further ado, let's get started, and we already did all this. Moving on to question number 7. Question number 7 says, iron is extracted from iron ore in blast furnace using limestone and coke, that is carbon. Name a common ore of iron. A common ore of iron that is studied in our syllabus is hematite, so that's what you're supposed to write. Moving on to part B, the coke burns to form carbon dioxide. The reaction is exothermic. Explain in terms of bond making and bond breaking why this reaction is exothermic. So the main reason why this reaction is exothermic is because more heat is released than it is absorbed. And when we're talking about exothermic reaction means release of heat. So if more heat is released, so it is automatically going to be exothermic reaction. But because we have to explain here in terms of bond making and bond breaking, so we are going to also mention that heat is absorbed while breaking bonds and heat is released while we are making bonds. So this is how you are going to solve this question. Moving on to part C, carbon dioxide reacts with hot coke to form carbon monoxide. The carbon monoxide reduces the iron 3 oxide in the iron ore. Using the equation to explain why Fe2O3 is reduced. Fe2O3 is reduced because, as we can see, that here on one side of the reaction we have oxygen with it. However, in the product side we do not have oxygen. That means it has lost its oxygen, which means it has reduced. Moving on to part 2. Okay, I've already solved this since it's a hassle to bring in calculator and then solve it in front of you everything, and it takes a lot of time and it's a lot of hassle. That is why I solved it before. So I'm going to explain you this question properly. First of all, the question says, calculate the maximum mass of iron formed when 12.5 gram of iron 3 oxide reacts with excess carbon monoxide. So first of all, I want you to understand this question. Here we are supposed to find the mass of carbon, and the mass of carbon according to this equation over here, and it is the amount of iron 3 oxide is given to us, and iron 3 oxide is 12.5 grams. Now if we see, so we have 12.5 grams of this and we need to find the mass of this. So here carbon monoxide is in excess, so there is nothing that we are supposed to consider. So first of all, we are going to find the moles of Fe2O3, because moles is the main thing that we are supposed to, that is going to help us to determine the amount of something. So 12.5 divided by 160. Why 160? Because Fe2O3, Fe has 56 its mass. So 56 plus 56 plus 16 into 3, and this is what you're going to get in answer. After dividing, we have found the moles. The formula for moles is mass upon the MR, the molecular mass. Alright, so we got this answer, that is 0.0768. We have found the moles for it. Now since we have double of it on the iron side, that means we have 2 Fe, so we are going to multiply now we are going to multiply it with 2, alright, to find the number of total moles. So we are going to do 0.0768 multiplied by 2, so we are going to find the moles in this way, the total moles of iron. And why did I multiply 56? Because we are supposed to find the mass of iron. So that is why the mass of iron as per periodic table, the AR of iron is 56. So we are going to multiply it, and here we will get the mass of iron. Pretty simple question, very basic moles question, and that's how you are going to get 2 marks. Moving on to part D. Part D says, silicon dioxide is an impurity in the iron ore. Explain how the addition of limestone helps to remove silicon dioxide from the blast furnace. So basically, limestone decomposes to calcium oxide, and then calcium oxide reacts with silicon dioxide and it forms slag. So this is how you're going to write its answer. Moving on to part E, iron is a metal. Describe metallic bonding. So what is metallic bonding? We have basically positive ions, and those positive ions are surrounded with a sea of electron. Alright. if you have studied this, I'm sure you have, you must have seen the structure in which we have positive ions together and the electron surrounding it randomly. So that random electron is known as CF electron. I'll always suggest you mention the word CF electron, since it's very specific for metallic bond and it gives a very clear picture that what you're trying to say. Alright, it gives a very clear picture of metallic bonding. And then about its attraction, we also supposed to do this. So there is electrostatic attraction between the ions and electrons that keep them together, forming a metallic bond. Alright, this is how you're going to write its answer, 2 marks, pretty simple. Moving on to part 8, this question is about some compound of sulfur. Part A says dilute sulfuric acid reacts with aqueous sodium hydroxide as shown. H2SO4 plus 2NaOH is equals to Na2SO4 and water. Part 1 says a student titrates 25 centimeter cube of dilute sulfuric acid with sodium hydroxide of concentration 0.015 moles. First of all, let's highlight it and let me hide the solution. Alright, so here we have 0.015 mole per dm cube of sodium hydroxide. Alright, and the volume of 24 centimeter cube of sodium hydroxide reacts exactly with the dilute sulfuric acid. So we have 24 centimeter cube of aqueous sodium hydroxide. Alright, now let's highlight the parts for the sulfuric acid. So we have 25 centimeter cube of sulfuric acid, which is the volume, since the unit tells us about it. Now the question says that calculate the concentration of dilute sulfuric acid. So for it, first of all, since we have greater data of sodium hydroxide, we can first of all determine the number of moles. And the number of moles can be determined by using the formula of volume into concentration is equals to moles. Alright. So N is equals to C into V. C is the concentration, V is the volume. We have volume 24 centimeter cube. This is the NaOH part. Alright, this part is for NaOH. Alright, and through NaOH we can easily find 24 upon 1000, which is 24 centimeter cube to dm cube, because we always use dm cube for volume and not centimeter cube. It's not the appropriate unit. So we're going to convert it by dividing it with 1000 and then multiplying it with the concentration we have. The answer is 3.6 into 10 to the power minus 4. In this way we have found the moles of, this is the moles for NaOH, and then because we have a ratio of 1:2, we are going to divide by 2 to find H2SO4. Moles of H2SO4, and that is 1.8 into 10 to the power minus 4. Now to find the concentration is equals to volume upon, concentration is equals to moles upon volume. So here are the moles and this is the volume. Again we had 25 centimeter cube of dilute sulfuric acid. We're going to convert it to dm cube, since our answer is also in dm cube, mole per dm cube. And then you are going to calculate it. You'll get the answer 7.2 into 10 to the power minus 3. This is how we're going to solve this question. I'm writing the formula over here, that is C is equals to N upon V. Alright, this is the formula that I have used here throughout the question. Moving on to part 2, describe how to prepare pure dry crystals of sodium sulfate from aqueous sodium sulfate. So for this, this is a crystallization method. You can describe the entire crystallization method as you do. First of all, we are going to evaporate this solution until it reaches a point, that is crystallization point. Alright, and crystallization point is achieved when the solution is saturated. And then after it we are going to filter out all the crystals. Alright, wash it with cold distilled water. Mainly why do we use cold water? Because cold water is not that reactive. Alright, we do not want any reaction to take place. So that can also be a contributing reason why we use cold water. And then moving on, however, in some cases we do use cold water in terms of reaction. Those are other cases, but generally cold water does not really react a lot, and distilled water to avoid any kind of impurities. And then we have we have the crystals with us. We are going to dry it out, and you can dry it out by keeping it between the filter papers. That is how you are going to frame this answer. This is a very basic question that we get related to crystallization. It is done using the same format. You just need to change the name of the chemicals and few things according to it. However, it has the same 3 steps, that is evaporate till saturation point, after it filter it out, and then clean it with distilled water, wash it, and then after it dry it between the filter paper. That's all. Moving on to part B, concentrated sulfuric acid oxidizes arsenic to arsenic 3 oxide. Complete the equation for this reaction. We're supposed to balance it. So since we have alright, let's balance this in this way. We have 4 arsenic over here. We can put 4 H2SO4, because here we do not need to balance anything, so for sure we are going to have 4 arsenic over here. Then we have 6 and 7, 8 oxygen already with us. Okay, so it's going to be something linked with it, so we are now going to balance this first. We have H2O, so let's balance it in such a way. Okay, so if we put 4 over here, so it is going to be 4H2, 4, alright, it's not balanced, so it's not going to be 4. We can put 6 over here for balancing it. So 6 and 6. This question is mainly done with trials and errors. You can do it. However, the greater you practice, the more better you will get at this section, that is balancing of equation. Moving on to part C, which says sulfur dichloride ClSCl has a simple molecular structure. Complete the dot and cross diagram for a molecule of sulfur dichloride. Include only the outer shell electrons. So here, first of all, we're going to look at it. Cl usually has 7 in its outer shell electron. In its outer shell, the number of electrons, and sulfur has 6 usually. Let me check. Let's see. I'm not sure. Let's find sulfur. 5, 6. Yeah, sulfur has 6 because it's in group 6. Alright, and Cl has 7 since it's in group 7. Alright. So now let's go back to our question. Here it is. Include only the outer shell electrons. So let's begin. We have so we have 1, 2. We have this one from sulfur and one from chlorine. Alright, because chloride requires chloride requires 1 electron to fulfill its octet. So we have given it 1 from sulfur. Rest of it 1 over here as well. Sulfur will give its 1 electron over here as well, and chlorine's 1 electron. For sulfur, in this way sulfur can be balanced out. We'll draw the rest of it, that is 1, 2, 3, 4. Alright, let me make it more better by using different colors. Alright, so it can be more clear. First of all, let's draw sulfur. We have 1, 2, 3, 4. Always remember, do not start drawing it as it is, like suddenly just you begin drawing the electrons. First of all, you need to know that sulfur has 6 in its outer shell and chlorine has 7, and this chlorine has 7. So this chlorine requires 1. That means sulfur and chlorine should share 1 electron, and this should share 1 electron. In this way it will have 8. Since sulfur is sharing 2 of its electron, so 6 plus 2 is equals to 8, and then chlorine again forms 1 bond, so like single bond, so it's going to be 8. 7 plus 1, 8. So for sulfur, we will be using this color. So sulfur has given 1 to its dischlorine and 1 to its dischloride. Chloride, sorry. 1, 2, 3, 4, 5, 6. Sulfur is completed. Now if we talk about chlorine, we can use, it's not really visible. For chlorine, it will share one of its electron with this sulfur and the other one with this. Rest of it you can draw over here. So 1, 2, 3, 4, 5, 6, and this is the 7th one. Now it is sharing, so it has 8 in its electron, in its octet. It has 8 to fill its octet. Alright, and this is how it is going to be done. Alright, I hope it's clear. Now you can see that every element has formed its bond, and now it has 8 in its octet, 8 electrons in its octet. Moving on to part B. Part D, the melting point of sulfur dichloride is minus 121 degrees Celsius. The boiling point of sulfur dichloride is 59 degrees Celsius. Reduce the state of sulfur dichloride at room temperature. Give reason for your answer. So basically over here, let me give you a brief explanation of this question. Melting point of sulfur dichloride is minus 121 degrees Celsius. That means if it is minus 120 degrees Celsius or lesser than it, it is going to be in its solid state. Then moving on to the boiling point, that means if it is 59 degrees Celsius or above 59 degrees Celsius, that means it is going to be in gaseous state. Alright, now we are talking about sulfur dichloride at room temperature. Now this sample of sulfur dichloride is kept at 26 degrees Celsius. We know that room temperature is 26 to 27 degrees Celsius, which is lesser than 59 degrees Celsius and higher than minus 121 degrees Celsius. That means it is neither in gaseous form nor in solid form, it is in liquid form. Alright, so the answer for this is liquid, and I gave you the whole explanation. You can write the answer according to it. Alright, that is it for this video. I hope you found it helpful. In case you have any request, make sure to put it in the comment box down below. Thank you so much for watching, and best of luck for your exams.